So this is the key ingredient. Building the triangle is wonderful, but getting from there to a polynomial is where it all starts to come together. All right. So if you look at, well, really each step of this progression, x plus y to the 0th power became a 1. All right. That's just because anything to the 0th power is equal to 1. But x plus y to the first became a 1x plus 1y. But more specifically, it's 1x to the first, 1y to the first. All right. X plus y to the second is 1x to the second, 2x to the first, y to the first, and then 1y to the second. All right, so what's happening if we just take note of the x's? The powers are decreasing. Power of 2, power of 1, then it disappears, so it must have been a power of 0. All right? The y's didn't exist at all in the first term, but then it became a y to the first, y to the second. So it's increasing in power. All right? And what is it increasing in power to? It's increasing in power to whatever the power was in the binomial, or the binomial is raised to. All right? So using that idea, we can work backwards and say, all right, so I'm going to start off with an x to the third, all right? Because this is really x plus y to the third. That's what we're looking for. So for consistency, we would want to write both, all right? Then it's going to decrease in power. So x to the second, x to the first, then x to the 0th if you want to write it. If not, then just ditch it because x to the 0th is going to 1 anyhow. All right? But I'll write it in anyway. Now, I know that the y term has to finish up the expression being raised to the power, whatever the power was in a binomial. So we're raising to a power of 3, so I need to end with a y cubed. And so I can decline my power going from right to left. All right? So instead of working from left to right like I did with the x's, work from right to left, power of 3, power of 2, power of 1, and then power of 0. Then lastly, I just need to put my coefficients in. All right? My coefficients are 1, 3, 3, 1. They're all positive. So I'll just use blue again. 1, 3, 3, 1, all positive. I don't need to lead off with a positive sign because it's just going to disappear anyway. But these coefficients become exactly what they are, coefficients within the polynomial. All right, now it's up to you if you want to simplify. Some people are fine just leaving it like this. I'm fine doing that, but it also kind of looks a little nicer. Oops. Assuming I write it correctly, of course. Xy squared plus y cubed. All right, and so that's the expansion of the polynomial. All right, it takes a little doing. You could have multiplied the previous answer, x squared plus 2xy plus y squared, by another x plus y. But then the question, the follow-up I would have for that is, well, what if I needed to raise it to the 7th power? You'd be here all day doing that. Question?
Yeah, can you scroll up a bit?
Oh, yeah, sure.
Or like move like the thing on the bottom like upward.
Oh, I see.
Thank you.
Yeah, no problem. All right, so now we have an expansion. Personally, I'd love to know if I did that right. All right, because that's a lot of work to screw up and then find out after the fact, right? So what I would do, you could actually do it a couple of ways. One way would be to try to type it in as a function. The problem is it's a function of x and y. So I'll just show you real quick. If I say x plus raised to the third power, Desmos does not understand what I'm talking about. All right, so what I do is I look for a true relationship between what we're starting off with, this guy over here, and this one. Right? And the way to do that is to create what we call dummy variables, just placeholder variables for x and y. Because Desmos is having a hard time with x and y because it thinks I'm trying to create a multivariable function. So if you have an equation that's in terms of two variables, that puts it into the third dimension. All right? We're working in a two-dimensional plane here, so Desmos is not going to be able to handle that. You'd have to go to something like GeoGebra. All right? But what it can do is it can evaluate expressions numerically. So what I would do is replace every x with an a and every y with a b. All right, so instead of x plus y squared, I'd type in a plus b squared. Cubed, sorry. That a to the b power is a cube. Now you see below it, it says add slider, a, b, and all. All right, you want to add sliders. All right, because what that'll do is it'll allow you to toggle the value of a and b and give you the resulting value of a plus b cubed based off of whatever you select. So I'll keep it simple. I'll put it at 0 and 1. 0 plus 1 is 1, cubed is 1. All right, so we know that this is a true sentence or a true expression. So what I would then do, so I got all that in there, I would type in my expanded form using a instead of x and b instead of y. So a cubed plus 3a squared b plus 3ab squared plus b cubed. Takes a little getting used to with Desmos, but it'll work once you take the time to type the stuff in. All right. So I have that expression. It's equivalent numerically to the a plus b cubed, but I want to make sure it's going to always be equivalent, not just for the instance where a is 0 and b is 1. So what I'll do is I'll slide my slider, just pick some arbitrary value for A and some arbitrary value for B and make sure they give the same values. All right. I could also animate my sliders. It just goes pretty quick. But if you have a pretty good eye, you can see that they're going to the same values just really, really fast. All right. You could slow it down. I'll put it at 0.05 for each one. All right. It's still going pretty fast, but it might be a little easier to see. All right. And you don't have to animate it. Just slide the sliders and see that they give the same result every time. All right. So the question becomes how do we translate this to the questions that you see on the paper? All right. So let me take you through D real quick. All right. So what D is asking us to do is raise our expression to the 5th power. So what I'll do is it's going to be the 6th row of Pascal's triangle. All right, that's, it can be a little confusing, but that's because the first row is the 0th power. All right, so it's always offset by 1. All right, so what I would do, well, I have x and y in the examples that I used when we constructed Pascal. Now I have 2x and a 1. All right, but we're going to essentially follow the same approach. So we have our coefficients, 1, 5, 10, 10, 5, 1. All right, so we'll hang on to that. But I would be thinking, all right, I have an A, not an A really. I used A in Desmos, but like the A and B values or the X and Y values, whatever you want to think of it as. But the first term contains a 2x instead of an x. So I'm going to take 2x and raise it to the fifth. Then 2x to the fourth, to the third, second, first, and 0th. Then I'm going to take the 1, starting on the right-hand side, and raise that to the 5th power, and then decrease my power as I go from right to left. You don't have to write it because 1 to any power is going to go to 1 anyway, but I'll put it in just so we have it. 1 to the 5th, 4th, 3rd, 2nd, 1st, and then 0th. So I've taken care of my variables. Now I'm just going to pop in my coefficients. So 1, positive 5, positive 10, another positive 10, another positive 5, and another 1. Oops, poor quality 1. All right, let me scroll that up. Best I can anyhow. All right, gets pretty messy, but now it's pretty easy to simplify. All right, if you need to. 2 to the 5th power is 32, so 32x to the 5th. 2 to the 4th is 16 times 5 is 80. 2 to the 3rd is 8 times 10 is we get another 80. X to the 3rd. Then 40 x squared. Then just a 10x. And then a 1. All right. If you're comfortable with Pascal's triangle, this ends up being an easier way to distribute out binomials, easier than actually physically taking the 2x plus 1, multiplying by 2x plus 1, getting that answer, multiplying it by another 2x plus 1. Right? That's not fun. All right. But like in the moment of truth, if you can't remember Pascal's triangle, start distributing. Right? Because to try to figure it out on the fly is a little tricky. All right. So that, as they say, is that. This one ends in 10 minutes. So you have some time. Sorry to talk so much, but I historically people have struggled with this concept. And so I got in the habit of always just going over Pascal's triangle.